Hello everyone, my name is Abhishek and welcome back to my channel. Today is day 2 of Terraform Zero to Hero series, and before I explain you what we will learn as part of day 2, let's quickly recap what we have learned on day 1. So on day 1, we started with understanding the concept of infrastructure as code, how and why Terraform is the key player in the space of infrastructure as code. After that, we learned how to install Terraform on Linux, Mac OS, and Windows. Apart from that, I've also explained you how to set up Terraform in GitHub code spaces. GitHub code spaces is very powerful because you get it for 60 hours free with 2 CPU and 4 GB RAM. So if you don't have a proper workstation or you are using your office laptop and you cannot install Terraform in it, so you should explore the option of GitHub code spaces. And after that, I have explained how to set up Terraform for AWS, because most of this series we will try to automate infrastructure on AWS. And in the last class, we have created EC2 instance. So I've explained you how to configure Terraform for AWS, how to give your AWS security credentials, all of these things. Then we moved ahead and understood the concept of Terraform lifecycle. What is Terraform plan? What is Terraform apply, init, destroy? All of these things we try to understand with example. And finally, I just touch the concept of Terraform state, because on day 4, we will deep dive into the concept of Terraform state file. What are the advantages of state file? What are the disadvantages of the state file? What is remote state? I mean, remote backend. All of these things will be covered as part of day 4. So you need to understand what is state file doing. So that's why I just explained the basic concepts of state file in day 1. Going back to the actual discussion for today, that is day 2. So what exactly are we going to learn as part of day 2? In today's video, we will learn what is provider in detail, what are the different types of providers, how to configure providers. We will talk about providers for multiple regions, providers for multiple cloud, that is the hybrid cloud. We will also learn that. And then I will explain you how to write resources in Terraform, what exactly is resources. Then we will understand about variables in Terraform, input variables, output variables, TF-vars. We will understand about these things. After that, we will learn about conditional expressions and functions in Terraform. Finally, I'll explain you about debugging and formatting in Terraform. So these are some of the things that we will cover today, and it is going to be power packed. If you look at day 2 folder, I have written the complete notes. Let's say at some point of the video you are not able to follow, then you can use this notes as your reference. For example, whatever I'll be talking about providers is already available here, and whatever I'll be talking about, let's say resources or variables, TF-vars, all of these things with examples is available. So please try to watch the video till the end, and after that you can recap by following the documentation. Just by following documentation or just by following the video, you will learn things. But to get 100% knowledge on what I'm explaining on day 2, follow the video till the end and quickly recap what we have provided in the day 2 folder. Providers. So there are some really cool scenario based interview questions related to providers, which we'll also try to cover in today's video. But before that, when we created EC2 instance on the AWS platform the other day, what is the first thing that we wrote in the main.tf file? So the very first thing that we have written in the main.tf file is the provider block. We said provider, inside the double quotes, we mentioned AWS, and within the braces, we provided the configuration of this. We said region, whatever the region that you would like to. And apart from that, if you want, you can also mention what is the AWS secret key, what is the access key ID. All of those things can also be mentioned in the provider block. But what if I don't mention this provider block itself? And if I just proceed with creating the EC2 instance logic, where I can just say resource followed by AWS underscore instance followed by the name of the resource, and inside the block I'll just mention what is my AMI ID, and I'll mention what is the instance type. For example, and I will just run Terraform init, and let's say this got succeeded, and I will run Terraform apply. So what will happen is, how will Terraform apply, or how will Terraform understand where it has to create this resource and how to authenticate to that particular cloud provider? All of that information is available through this provider block. So provider is nothing but, provider is a plugin that helps AWS, sorry, that helps Terraform to understand where it has to create the infrastructure, right? So it acts as a medium for Terraform to understand where these resources or where the entire project has to be created. Without provider, it is not possible. Now, what if, instead of AWS, what if you want to create infrastructure on Azure, GCP, Alibaba Cloud? So where will I understand how to configure this provider, right? So if it is AWS, I told in the last video that this is how we have to do. Don't worry, you can just go to the Terraform providers page, and there are hundreds of providers. As of today, Terraform provide so many providers, but there are categorized into three types: official providers, partner providers, and community providers. Official providers, like if you uncheck these other two things, right, bunch of things will go away. Official providers are the ones that HashiCorp actively maintains. So HashiCorp is the creator of Terraform, and they actively maintain these providers like AWS, Azure, Google Cloud Platform, and Kubernetes. So you can trust them. You can you can rely on these providers because there is someone who is backing up these providers. Whereas the other things are partner providers and community providers. So partner providers are these ones where, let's say, Alibaba Cloud, HashiCorp did not create the provider for them. What Alibaba Cloud said is, okay, we will write the resources. We will tell Terraform how to authenticate with us and how to create infrastructure on us, and we will actively maintain this particular provider. That is Alibaba Cloud, Oracle, and some others. Now, apart from that, there is something called as community providers, where community providers are something where you and I can also create the entire provider configuration, and open source will maintain these providers, right? There is no official backing up by HashiCorp or official backing up by partner providers or any partners of HashiCorp. So you don't have to worry this that much. But only thing is, let's say in your organization, you are trying to automate something very different, like apart from AWS, Azure, or Google Cloud Platform. Let's say you are using a different cloud, or you are trying to create infrastructure somewhere else. You have to make sure that at least if it is community provider, there is some active contributions that are made to it, right? If there are no active contributions made to it, then it is not that much suggested to use that Terraform provider. Apart from that, if you're using partner or official providers, there is no problem at all. Now, going back to the topic, if you want to look at the configuration, or if you want to read about particular provider, just click on these buttons and you will learn everything about that particular provider, right? When are the last updates, how to use that particular providers, how to write configuration for them, everything is available. But in the interviews, usually interviewers focus on a couple of things. That is, in yesterday's video, we learned how to create in a particular region. But what if you want to use multi-region, right? You want to use Terraform to set up infrastructure in multiple regions. Or how do you set up Terraform to create infrastructure on multiple cloud? That is, if your organization is on hybrid cloud, then how do you use Terraform? These are two popular things. One is the hybrid cloud architecture of Terraform, and the other is multi-region setup of Terraform. So how do you do that? Because in yesterday's video, we just wrote provider for one particular region. So don't worry. What you do is you just mention. So if you go back to the document here, I have provided both the examples. This is for multi-provider and this is for multi-region. Let's start with multi-region. So let's say you're using AWS and you want to automate infrastructure on US East 1 as well as US West 2. So what you will do is, instead of one provider block, you will write two provider blocks. So in the first provider block, you will say that provider is AWS And watch this carefully. You will use a keyword called alias. And for US West 2, again you will write the provider block and you will create a different alias. And when you are trying to create EC2 instance, exactly what we have done yesterday, we have just written these two things, right? We said resource, AWS instance, example, and we provided what is the AMI and what is the instance type. Apart from that, when you want to create resources in multiple regions, you can create a alias for your provider, and within that particular resource block, you can say provider is equals to AWS dot the name of the alias. So here I said AWS dot, what is the value of the alias? US East 1. So by looking at this, Terraform will understand that, okay, I have to create this resource on the provider called AWS dot US East 1. That is this particular thing, AWS dot US East 1. Sorry, this one, AWS dot US East 1. It will go to the alias, and there it will identify, okay, my region is US East 1. So this alias can be anything. It does not have to be similar to the region name. You can just call it as ABC, XYZ, whatever you would like to. Got it? So this is how you set up Terraform for multiple region. Now, how do you set up Terraform for multiple cloud? So this is about multi-region. But what if your organization is in hybrid cloud? In such cases, similar to the above, but here you will configure providers with different names. So AWS has the provider name as AWS, whereas Azure has the provider name as Azure RM. That's why I showed you, you need to go to the official documentation, because without going to the documentation, you will not understand what should you provide the name here, right? So let's say I will go to Azure. Here I will understand that, okay, the name of the Azure provider is Azure RM. So that's why if you watch carefully here, in the first block, I've wrote provider AWS. In the second block, I've written provider Azure RM. And inside that, similar to AWS configuration, for Azure, you will have a different configuration, right? For AWS, you just mention what is the region. And if you're using AWS CLI to configure it, which is something that we did yesterday. So that's why we did not provide any AWS credentials. But if you don't use AWS CLI to authenticate, then here you have to mention what is your access key ID, what is your secret access key ID. That's what we are doing in Azure as well. What is the subscription ID? What is client ID, client secret, and tenant ID? Because Azure has a different mechanism, right? In Azure, you have service principal, whereas in AWS, you typically go with the IAM thing. And after that, it is very, very common. Once you provide both of these things, it is the resources. Like for AWS, the resource name would be AWS instance to create a virtual machine. For Azure, the resource would be Azure RM. Now you might ask me, but Abhishek, if I have to write this block, if I have to create resources on Azure, how will I understand? How do you know? Like maybe if I am writing, how do I know? So it is very simple. Just go to the Terraform Azure, right? Docs overview, HashiCorp Azure RM. Now nobody, whoever the DevOps engineer is, whoever the cloud engineer is, nobody will remember all of these things, right? Nobody can remember what is the name for AWS for virtual machine, what is the resource name for virtual machine in Azure, and there are hundreds of resources in AWS. There are hundreds of resources in Azure. So even if you are working in an organization, you will not have that complete knowledge. You just have to go to the official documentation, and in the official documentation, you have to search for it. So what did I do? I just searched for virtual machine and I got this. What is it called? Azure RM underscore virtual machine. So that's why I wrote resource Azure RM underscore virtual machine. And here you will have bunch of examples as well. So using these examples, like for example, this is how you write this one, right? For writing virtual machine. So this is the block. So Azure provider is already giving you some examples. What you need to do is you need to take these examples. You have to modify it accordingly. That is what we will learn in this series. Don't worry. But at this point of time, when you are trying to understand what is resources, it is my responsibility to tell you that anyone, whether they are working professionals, they have 10 years experience, 15 years experience, still We have to reference the documentation because you cannot remember all of these things. And if you try to remember, then you are wasting your time. In your interviews, when someone asks you, you can just tell them that I don't remember the syntax 100%, but I can give you a rough overview. And that is what is expected in your interviews as well. Nobody will expect you to write this entire thing as is, because this is not a program, right? This is taken from the documentation. This is according to the Azure RM documentation. Got it? So you should be able to understand, if you want to create a virtual machine, what you need to write, you need to know the skeleton. Okay, we will do that when we go to a project. I will explain you step by step how to do that, don't worry. But at this point of time, just understand that resource you will get from the official documentation. You can take help of official documentation. And what is this resource indicating? In AWS, if you want to create EC2 instance, this resource indicates that for EC2 instance, you are writing this block of code. In Azure, if you want to create virtual machine, so for Azure virtual machine, you are writing this block of code. One more thing you have to understand is, if you don't know how to create resources manually on AWS, or if you don't know how to create resources manually on Azure, then learning Terraform will not be helpful at all. I'm again telling you, if you are directly trying to learn Terraform without understanding the concept of AWS cloud provider, without understanding how to create, let's say your task is to create VPC using Terraform. And if you don't know how to create VPC from the UI, then do not learn Terraform. Firstly, go and learn how to create resources on AWS, because that is the same thing that we'll try to put in implementation in Terraform. Okay, perfect. So you understood what is providers, you understood how to configure multiple provider, you understood how to set up multi-region architecture in Terraform. Then let's move to another concept, which is called as variables. Now, variables is quite common. Any programming language that you are trying to learn, or any scripting that you are trying to learn, you will use variables. What is the advantage of using variables? Variables is used to parameterize. Okay, so they can be used as params to pass values to your projects. Same in Terraform. What you will try to do is, let's say you write a standard Terraform project, and this Terraform project is used by one particular team. Later, other team comes up with the same request. So if you are hard coding the values in the Terraform, if you go back to yesterday's learning, so what did I do here? Because that was our first project. In the main.tf, I have hard coded the AMI value. I have hard coded the instance type. But this is not a good practice. Why? Because if some other team, as a DevOps person, you will support multiple teams. So let's say some other team comes to you and tells that, Abhishek, I want a Terraform project for creating EC2 instance. You already have one. Why you want to write this again and again? If you are hard coding the AMI value, and if you are hard coding the instance type, that is what you will do. You will rewrite this entire project for another team. So to solve this problem, what you will do is, instead of providing the AMI value as a string like this, you can replace this with a variable. Instead of writing instance type value in a string like this, you can replace that using a variable. And in Terraform, there are typically two types of variables. One is called as input variable, and the other is called as output variable. What is input variable and what is output variable? Let's say you want to pass some information to Terraform, then it is called as input variable. Or if you want Terraform to print a particular value in the output. Yesterday, when we created EC2 instance, when we performed Terraform apply, we saw that Terraform is giving back a bunch of information, right? Or Terraform just said that one resource is created. But let's say after the EC2 instance creation, you don't want to go to the AWS UI and you don't want to check the public IP. Let's say your EC2 instance is available publicly. So what you can do here is, in the output variable, I'll show you the format as well. You can tell Terraform that print the public IP. And what will happen is, every time this Terraform project is run, once the Terraform creates resources on AWS, As an output, it will give you public IP back. You can see the public IP on your console. And input variables, we all know what input variables are. The same example that I talked about. If you want to parameterize AMI in the above example, or if you want to parameterize instance type in the above example, then you need to pass those things as an input variables. I'll show you some examples. So here the examples are also available. So instead of creating the resource, here I have created an example resource, and what did I provide the name of the resource as? var.example_var. And where did I create this example var? I have created using this syntax. Now let me explain how to do it for an EC2 instance, because you all know at this point of time how to create an EC2 instance using Terraform. So let me explain that here itself. Now I will create something called as main.tf. Okay, inside the main.tf, as usually, I'll write the provider configuration, or I can write the provider configuration in the provider.tf as well. Let's say I've written that in the main.tf. I wrote a bunch of things inside the provider configuration. Then what I'll do is I will say resource AWS_instance. Just provide a name of the resource. Let's call it as example. And inside that, instead of hard coding the AMI, okay, what I'll do, AMI is equals to var.AMI_value. And instance type, what I'll say is var.instance_type. But where will I get these variables from? So what you need to do is before the resource, okay, in between the provider and resource configuration, what you will try to do here is you will write all the variables that you want to use. So here you can see the variable implementation. So I've created two files. One is variables.md, which has information of whatever I've explained till now. So all of these things you can summarize. This particular file called variable.tf, here I've written the same script that we used yesterday. Yesterday we used main.tf and we just created the resource directly, right? We created this particular resource. But here if you see today, what I did is I replaced this thing with var.AMI_ID. What did we do in yesterday's class? Let me take that in a different tab. Okay. So here, if you see, this is the main.tf that we used yesterday, and these fields are hard coded. This is the AMI and this is T2 micro. Whereas in today's video, here I said AMI is equals to var.AMI_ID. Instance type is equals to var.instance type. And where am I getting these fields from? So before you write the resource block, you need to create these variables. Okay. And this is the syntax for creating a variable. Let's see what would be the fields that would be going inside it. First, you start with the keyword called variable. And after that, you should be providing what is the name of the variable that you want to use. So here, the name of the variable I want to use is instance ID. So instance type is equals to var.instance type. So here I'll say variable instance type, and inside it, description is not mandatory. You can avoid description, but just for the readability, whoever is reading your project, they need to understand. This is very, very important in any programming language. When you are creating a variable, if it is a statically typed programming language, okay, I'll not go into the details of it, but you will mention what is the type of a variable, right? So here the type of the variable is a string. It can be Boolean or it can be any other kind as well. So here the type of the variable is string, and what is the default value? T2 micro. Now whenever you use this particular variable using var.name of the variable, so var.instance type, see, that is what is referenced here. What would be replaced when you use var.instance type? This particular var.instance type would be replaced with the default value, that is T2 micro. If you don't have a default value, I'll explain you what you need to do. But when you provide default, what will happen is the var.instance type would be replaced with this particular thing. So what will happen with this is you are not hard coding these fields. You are using that in a separate variable section, and you can update this variable section from the Terraform apply command as well. That means you can pass the values to these variables from the Terraform apply command, or you can put the values of this in a different Terraform file as well, which is called tfvars. I'll talk about it in a couple of minutes. But for now, I hope you understood what exactly we are trying to do using variables. We are trying to parameterize our Terraform project so that it is not just used by one particular team that you are supporting as a DevOps member. You can redistribute or you can reuse this particular Terraform project with a different team. Got it? So these are the input variables. Okay, whatever you are trying to pass here, these two information you are trying to pass to the Terraform project. So these are called input variables. Whereas you can also use output variables, but the syntax will be slightly different. The syntax for the output variables will start with output keyword, which you are asking Terraform to give back once the Terraform apply command is successful. Let's say I want to get the AWS instance public IP. So I'll say output public IP, and here I'll mention what is the value that I'm looking for. So I am looking for the public IP of AWS instance dot example instance. This is the one, right? Resource name dot resource keyword dot, or you can just say that AWS instance, which is the resource dot resource name. I think this is perfect. You can call it as resource dot resource name. Let's say you want for a different EC2 instance, you will say AWS instance dot example instance 2, or whatever is the name of that particular resource, and followed by the public IP, because you are looking for the public IP, right? So when you use output as a keyword, you are telling Terraform to give me that particular information. When you are providing or when you are prefixing with variable as a keyword, you are telling Terraform that take this as value, right? So this is nothing but input variables and output variables. The other important thing is whenever you write Terraform projects in your organization, right now we are writing very simple Terraform projects, but there will be a structure for your Terraform project, because you cannot write everything in one simple main.tf. So what you will do is you will split this. The provider configuration from the main.tf can be written in provider.tf file. The input variables that you are trying to pass, whatever we saw till now, they can be provided in the input.tf. The output variables can be provided in the output.tf. This is a standard practice. You can change the names of these files, but if you use this standard way, anybody who is reading your project, they will understand. And then you can have a file called main.tf, right? So this is a structure that is commonly followed. And apart from this, there is something called Terraform.tfvars. Now this is very, very important to understand, and I'll make it very, very simple for you. So here we are using variables, right? And if you are passing default value to a variable, that is fine. But how to parameterize completely? That means when you are executing this particular Terraform project, I want to take the values of this variable dynamically. So this instance type for one project that the DevOps team is supporting is T2 micro. But tomorrow someone comes and execute this, they want the instance type to be T2 medium. Someone wants T1 micro. So how to completely parameterize it, or how to pass the value to this variable? In Terraform, there is a concept called tfvars. Okay, so tfvars, you can let me go back. Yeah, so this is the tfvars file where I've written. Using tfvars, what you will try to do is you will try to put the values to these variables. That means you wrote this entire files, you wrote the input.tf, you wrote the output.tf. Along with that, you can create a file called terraform.tfvars, and inside the terraform tfvars file, you will write that AWS underscore instance is equals to T2 medium, or instance type is equals to T2 dot medium. Don't worry, we will do the practicals for each and everything. Here I'm just trying to explain you the concepts. So this is theoretical understanding. When we move to practical, you will understand in detail how to write each and every file. So in terraform.tf vars file, you will write the actual values of these variables. Okay, so what is the advantage of that? Tomorrow, any team that tries to execute this entire project, they can just change the tf vars file. Or let's say you have the Terraform project for dev environment, staging environment, and production environment. Okay, so you want to use the same Terraform project for different environments. Okay, and for one environment, your Terraform script for the EC2 instance, the Terraform instance type for the dev environment is T2 micro, whereas for production environment, the value is T2 medium, or it can be different from project to project. So what you will do is inside the input.tf, you will create that variable, but inside the terraform.tf vars, you will actually pass the value to it. It is just like a key value pair file where inside that file, you will write values of each and every variable that you are creating in input.tf. Let's say you want to write the value of instance type. So you will just say instance underscore type is equals to T2 micro. Then key value pair, let's say key name is equals to something. Let's say you want to provide some information about security groups, subnet IDs. All of these things you can provide in this tf-vars file. And when you run Terraform apply, by default, Terraform will look for this file called terraform.tf-vars, and it will replace or it will update the values in the input.tf, right? Whatever you provide in the input.tf, here, this value called AMI ID would be updated from the tf-vars. I mean, this particular thing, the default will be updated with whatever you provide in the tf-vars. If there is no default value, even then the tf-vars value will be taken as the AMI ID. So advantage that you are getting is, if some other team is trying to use the same project, they can simply update the tf-vars file. Okay, when we move towards the practical, you can see in live how we are doing it. There is also one example that I'm giving for today, but in another class, we will try to do the complete demo. And during that demo, we will write each and every file that we are talking about. We will write input.tf, we will write output.tf, main.tf, tf-vars, everything will be written. Don't worry about it. Okay, so tf-vars file, by default, the name is terraform.tf-vars. If you want to change it, let's say you want to call it as dev.tf-vars. In such case, what you will do is you need to pass that information to the Terraform apply command. Okay, you will say what is the name of the tf-vars. If you are using terraform.tf-vars, you don't need to pass that to the Terraform apply. But if you are changing the name, you need to pass that to the Terraform apply. Got it? So this is about input variables, output variables, and tf-vars file. Apart from that, what is left for us to learn today in today's class is what is conditional expressions in Terraform. This is again a very good concept. So conditional expressions are nothing but, in some cases, you want to execute. Let's say there is a resource block. Okay, and this particular resource block called, we will use the same example, AWS underscore instance. Okay, and in that particular resource, you want to execute some values. Okay, let's say there are 10 values, or let's say there are 12 values, and you want to execute 12 of these values on dev environment. Whereas if it is a prod AWS cluster or prod AWS environment, you want to modify value of a couple of fields, or you don't want couple of fields to be executed. I'll take a very simple example. Let's say you have a S3 bucket. If you are creating S3 bucket on dev cluster, that is on the dev AWS environment, let's say you want to enable public bucket access, just for easy thing. right? If you enable public access, you can simply host a static website. Whereas if it is a prod cluster, you don't want to enable the public access to the S3 bucket. So what are you trying to do here? You are trying to perform conditional actions. If you are aware of any programming language, such situations usually are handled by if conditions, right? In programming language, you usually have if conditions, else conditions, whereas in Terraform, you have something called as conditional operators. So the syntax for the conditional operator is, firstly, you will provide the condition. If the condition is true, you will execute the true value, that is the first value. If the condition fails, then you will execute the second value. I'll show you. So let's take example here. This is a very simple example where what you are trying to do is you are trying to create a resource called security group. In AWS, you want to create a security group. You have provided the name of the security group. You have provided the description of the security group. And in the security group, you are saying allow 22, which is allow SSH, but only, only allow for a only allow for a particular CIDR block. That means allow SSH to this particular instance where the security group is assigned, where if the environment is production, then assign this particular CIDR block. Okay. If the environment is not production, then assign this particular CIDR block. That is, if the environment is production, if it is a production AWS cluster, production AWS environment, you will allow SSH access to one particular subnet range. If it is dev environment, you will allow SSH access to the instance to a particular subnet block. So here I have used variables. What did I say? At var.production subnet CIDR. What is var.production subnet CIDR? The default value is 10.0.1.0-24. Whereas for the development, the value is 10.0.2.0-24. So if this condition is matching, then SSH access is allowed for this particular subnet block. If the condition is failing, SSH access is allowed for this particular subnet range. Got it? So this is how you can use some conditional blocks, right, in Terraform. This is very, very handy. I just took example of security group. You can take any other examples like I provided, let's say S3 bucket access, right? Do you want to keep it public for dev environment? If you want to keep it public, then you can use this CIDR, you can use this conditional operator and say that if your S3 bucket is on the production environment, disable public access. If it is on the dev environment, enable public access. You can use the similar kind of condition, right? var.environment equals to production, then true and false. Got it? So right now you might not be knowing how to create resource for S3 bucket. Of course, you will go to the documentation, and what you will do is you will see all of these parameter, and for one of the parameter where they have public access enabled or disabled, you will use this particular condition. So this condition is also called conditional operator. In some programming language, we use this as if and else conditions. You can call it anything that you would like in Terraform, but the concept that you need to understand is they are helping you to execute resources using conditions. Got it? So this is very, very important in Terraform. When you try to use Terraform for multiple environments, when you try to create Terraform complicated infrastructure, you will use the conditional operator. Then if we go back, we have something called as built-in functions. So in built-in functions, of course, you cannot learn these built-in functions without actually using them, because again, they are like keywords. And if at all there is a use case, you will use particular thing. If you don't have use case, then you will forget about it. So this thing comes with practice, but you need to understand that just like any other programming language, there are some built-in functions for Terraform as well. For example, you have a built-in function called length. If you append length before a particular list, then it will give you the output, which is the length of that particular list. Similarly, you have map, where if you provide a key and a value, this particular map keyword or this particular map built-in function, it will convert the output into the map format, into the key value format, right? So I've given bunch of built-in functions. This is just for your reference. The reason why I've provided you this built-in functions in this class is when you are learning about variables, when you are learning about the operators, I thought it is important for you to understand that there is something called built-in functions, and you can just go over this particular document. And if at all we will be using this when we create infrastructure, when we do project in Terraform, then I'll let you know that we are using a built-in function. Like I told you in day 2, this is how you have to reference it. So this is today's video. There is also a project which I have already explained in my AWS Zero to Hero class. We have collaborated with CloudChamp and we have created it. So for people who already have watched that, you don't have to again go to it and you don't have to perform it. But if you are a new learner of Terraform and you did not watch that particular video, you can just go to this particular project and you can read through the information. This is again a very simple one. I did not use any input.tf. I did not use any output.tf. I just created all of the things inside the main.tf itself. So you can quickly walk through this entire main.tf and understand how this is written. But don't worry, like I told you, the main.tf, input.tf, output.tf, and the entire structure of the Terraform with the demo will be performed in this Terraform Zero to Hero series, where you will understand end to end. So that's all I have for today's video. I hope you found this informative. Before going towards the next class, please try to read everything that I tried to put here. I've taken so much time in writing all of this information. So I hope you'll find it useful and share it with people who are trying to learn Terraform. Thank you so much. See you all in the next video. Take care. Bye bye.